you have mechanical systems. Then the user can then say, okay, do we want a 53-story building or do we want to split it into two? So very rapid iterations can start happening very early on in the process. It's all built on open standards. The foundation of everything we do is built on open standards. How can we link to other applications? We don't want it to all be trapped just even in our own tool. We need to be able to interact with the rest of the world. So as the designer is working on this, they can be connecting to Ecotect and doing, Ecotect is another energy analysis tool, and they can do an analysis of the building from that perspective. Or connect to SketchUp and say, one person might say, I'm just going to study the exterior wall of the building, what kind of a glazing is going to happen on it. So each user has their tool of choice, but they're all talking about the same building because they're pulling the data from this model server into their tool and then doing their analysis and posting it back, which then starts triggering other kinds of discussions. So a group called Whitestone Research was doing operations and maintenance life cycle costs of the building. As a designer was designing the building and saying, here's how many square feet of window we have on the building, Whitestone would be saying, well, here's how much it's going to cost you to maintain that building and clean those windows, or how much energy you're going to be using for the building. So it's about very early what we call creating the train wrecks. You want to create train wrecks early in the process and then get interaction from many teams. So the BIM storms, we've had thousands and thousands of buildings like this. They're open to the industry. Anybody can participate for free. They mimic the actual projects that we do with groups like the Homeland Security, Department of Homeland Security and GSA. We can't show those projects, so we've decided to open this up as a way to interact with others, and that's what we're doing at Connectivity Week. We're looking for ways to connect to other vendors, other systems, other organizations that have data that we can pull and push through web services or through open standards links to projects such as this. So here's Ecotect. We were working through the internet. So Ecotect was in London, we were in Los Angeles, and teams, other 130 teams were spread out throughout the world. The goal here was to not recreate the data in multiple tools. So the geometries that you see here of the city model actually originated in our tool. So as we were moving models around, they were pulling it from our tool into Ecotect and doing a thermal analysis of the context of the city, of that area of the city. Or looking at a single floor and saying, here's the lighting characteristics of the 34th floor of that building. And by doing that, this is all within the first few hours of the project. We're rapidly ramping up that kind of discussion to say, what kind of decisions can we make? Okay, so what we're going to be showing here live in a second is how we're connecting energy data to this particular BIM storm process. This is a Google Earth view. Google Earth is one of the tools that we use, and the way that we use it is Google Earth is a viewer that's looking at our model server, the BIM model server, and each of the dots can be a building or a piece of equipment. So let me show the next slide. If you zoom into this, you start seeing dots on a map, dots on a city model. Zoom into that, and you start seeing buildings. This is our application now, and then this application, the Onuma system, is pushing building data out to Google Earth. So as you change stuff here, it actually updates live in Google Earth. It's a network link. You're not downloading the building and installing and inserting it into Google Earth. Google Earth is actually looking to our server. So if a user here is moving this building and changing the size of it, it'll actually update here as well. If the VROC server, which has sensor data, says here's a temperature of this space or the condition of this air handling unit, that's what these dots are over here, it would actually update and show itself up in Google Earth. So we're mashing a lot of things together from different sources to be able to visualize what's going on in the building. So again, it's not just for viewing data, but if you have the right access, I could edit it here. So just like when you log into your any kind of system on the internet and you want to create an email, for example, you only can work with your own email address. It's the same way here. Every user has an identity, and we know what they're allowed to see, to edit, to add to, and to link to. Geospatial data is very important, so everything has a latitude and longitude down to the furniture and equipment level. The other important part of this is because this is happening live and in real time, we deliver just the minimal amount of data that's needed for that decision process. So for a building like this, you'll notice that each block here is a space. If we're dealing with space and energy and temperature, we're interested in spaces. We don't care about the doorknobs on the door or the structural system in the building. There's another view and another tool that would be interested in that, but we're keeping the model lightweight so you can push it through the internet live. So we're not downloading the entire model. When we're looking at a floor plan like that, it's only loading that part of the floor plan and looking at the data. In that case, we're seeing temperature data changing. Here's the sensor data coming from the VROC server into our system, saying here's the temperature of the room, and then our system pushing it out to Google Earth and saying here's a color-coded view of that temperature of that space or the condition of the equipment. In Google Earth also, when you click on objects in Google Earth, it's not just the geometry. This data says the square footage of the building and the energy use, or any kind of data that's coming from our system can also be pushed into Google Earth. So Google Earth is we've been using this a lot with our clients because it makes it simple to view data by users that know nothing about BIM or GIS or real-time data. They just say, we want to have an interface to get to simple information about that project. And that's, I think, going to be, the need of the industry is going to be something like that. How do we keep the interface simple so more users can interact directly with it? We don't want to have to wait for that report to come out. You want to look at that data in real time. And other things like connecting webcams to that location. So connecting a webcam to a website is not that magical, but connecting a webcam to an actual building, so it actually has a location and a plan, and has latitude and longitude, and you can actually move that webcam around or that piece of equipment is pretty exciting to see. We have a lot of clients that are interested in doing things like that. So here's a lighting schedule. Again, the data, we're not saving a geometry or a graphic saying here's the color-coded schedule of when the lights are on in a certain space. It's coming directly from the sensor. If a sensor exists in the space that says here's the temperature or the lighting condition of that room, you'd be able to see that like that. Or the real-time occupancy sensor. So it's endless. It really makes it completely open to what type of data you want to see. So again, in Google Earth coming from our system, the Onuma server to Google Earth, the sensor data coming from the VROC server saying here's a temperature of that return air on that on that air handling unit for that space. So there's a lot of different stakeholders in the Building Smart Alliance. It's about open standards, connecting building information modeling in an open standard format, and we're very much tied into that. It should not be stovepiped, and as we all know, a lot of facilities operate like this. They typically have binders and information that's stuck in either CDs or hard to use data formats or even paper formats still. A lot of our clients are still stuck in paper, and it's hard to imagine managing information in that format. Keeping it digital, keeping the data open, and being able to see things in real time allows collaboration among many stakeholders. Here's another view of, now this is our interface. So instead of Google Earth now, we're basically clicking on the space in our interface, and it's bringing up the same sensor data. So we're not having to recreate it in two spots. Some users might only look at it in Google Earth, others might look at it in our system, and you can drill down. It's a very simple interface in our system where we have a site plan level view, a floor level view, or a room level view. Here we're at the floor plan, and we can see multiple rooms, or you could drill down and see a single room. So the interface is basically web-based, and you just keep clicking and getting inside that space. Another one is actually to layer in engineering rules on top of that. So here's a view of a floor plan that says here is the temperature of the room, and based on previous engineering assumptions, here are the rooms that are out of range of what the room was designed to operate at, for example. Or color code with this pie chart which spaces have inefficient reheating based on engineering rules that were applied to that. So we're capturing the decisions that were made during the design of the operations phase and being able to graphically show them in real time as a facility owner would open up a plan like this. And drilling down to equipment level. So you can drill down to an individual piece of equipment, air handling unit or a VAV box, and see that piece of equipment and the data changing as that equipment reports from the sensors that's coming from the VROC server again. 2D and 3D, it's web-based, so you don't install software. It works on a Mac or a PC. It doesn't have a heavy hardware requirement, which means even like a netbook can give access to it. We have even an iPhone or iPad interface to some of the data. You can start interacting with that. So keeping the data simple and lightweight and being able to kind of use it cross-platform in different formats. Okay, a lot of the work that we're doing right now with the Department of Homeland Security, GSA, and others, we're representing the owner. The owners are starting to ask for things like this. They want to be able to track performance metrics of their building, or to be able to communicate to the architectural and engineering teams what their building requires in the design process. So for example, in a typical design process, the owner says, well, here's 1,000 pages of documents, here's the engineering specification requirements that we want for space, hand that to the design team, and they have to digest that and give back a CAD file or a BIM file saying, here's our design. We actually flip that around and say, let's take that data, the requirements, put it into our system, the Onuma system, and then do the iterations of what ifs here real quickly, and then export that out to other CAD or BIM applications. This is Revit right here. The Revit model is automatically generated, so these spaces could have started in an Excel file that said, here